In this video, I'm going to run through the interpretation of the model results. And we've covered this in the previous few videos, so this just brings everything together that we've talked about so far. So we are working with homes data. So if I just remind you what that data looked like, we've got 5 houses with sale prices and floor sizes. Sale prices in hundreds of thousands of dollars and floor sizes in thousands of square feet. And we fit the model, simple linear regression model with response variable price and predictor variable floor, and we got these results here. So I've just summarized all the results on this one page. The only other piece that I have here is we've got confidence intervals for the model parameters. Okay, so how do we interpret all of these numbers? So we can say that we found a statistically significant straight line relationship at a 5% significance level between y equals sale price in thousands of dollars. Sorry, thousands of dollars. Y is measured in thousands of dollars, not hundreds of thousands of dollars, thousands of dollars. And x equals floor size in thousands of square feet. So where are we getting that result from? Well, that's coming from a hypothesis test for the slope. And in particular, we could look at this two-tailed p-value here. Note that it's less than the significance level of 0.05, and that allows us to reject the null hypothesis in favor of the alternative hypothesis that the population slope is not 0. And then this is the interpretation of that hypothesis test. The estimated equation is given by y hat equals b0 hat plus b1 hat x, and if we plug in the numbers from the output here, 190.3 and 40.8, we get this formula here, y hat equals 190.3 plus 40.8 times x. Let's interpret those two parameter estimates. So first of all, let's look at the 190.3. So the y-intercept has definition that it is the expected value of y when x equals 0, but only if x equals 0 makes sense for the particular application and if we have data close to x equals 0. And neither of those things are true in this case, so we cannot meaningfully interpret the y-intercept in this case. The 40.8 though, that does have meaning, and it's the slope, so it's rise over run, so it's the expected change in sale price when floor size increases by 1 unit. So when floor size increases by 1,000 square feet, sale price would be expected to increase by $40.8 thousand or $40,800. It's a little more meaningful to divide both those two numbers by 10 so that we get something that's more meaningful in this context, and so we can say that we would expect sale price to increase by $4,080 when floor size increases by 100 square feet. And that's applicable to houses that are in the population that we're looking at here. And the sample that we're looking at here is houses between 1,683 and 2,269 square feet. And then the confidence interval. So the confidence interval was provided in the R output here. So we're 95% confident that sale price increases between $2,270 and $5,890 when floor size increases 100 square feet. Next, we can interpret the regression standard error, 2.786. R calls it the residual standard error, but in this textbook I call it the regression standard error. So remember, to interpret this number, we multiply it by 2, and then that gives us an approximate 95% prediction interval. So we can expect a prediction of an unobserved sale price from a particular floor size to be accurate within about approximately plus or minus $5,570 with 95% confidence. And then finally, we can interpret this number here, r squared 0.945. So that means that 94.5% of the variation in sale price about its mean can be explained by a straight line relationship between sale price and floor size. And then finally, a picture's worth 1,000 words, so we can draw a picture of the results. So the most appropriate picture to draw here is a scatter plot with price on the vertical axis, floor size on the horizontal axis. The points are plotted here, the 5 different houses, and then this line is the fitted regression line. Price hat equals 190.3 plus 40.8 times floor. So this equation allows us to predict the sale price for any house based on its floor size. So for example, a floor size with 1,800 square feet, a house with a floor size of 1,800 square feet would be predicted to have a sale price given by the point on the line there, which, what's that, about $263,000. And we can calculate that more accurately by using this equation and plugging in the value 1.8. So that's how to summarize all the results in a simple linear regression analysis. And in the next video, we'll go on and talk about how we can use our model to either estimate an expected value of y for a particular value of x, or predict an individual value of y for a particular value of x.